It's time to begin. Hello everybody. My name is Thomas Guerin. I'm an Android and Java developer at Xebia France. And today I'm going to talk about Google Cloud Messaging. This presentation is divided into 4 parts. First, I will describe what is Google Cloud Messaging and why you should use it in your project. Then I will show you how to set up GCM in both in your server and mobile application. And finally, I will talk about some news about GCM. So let's move on and see what is Google Cloud Messaging. In many modern mobile applications, one key feature is to display the most up-to-date data to your user. One possible way to do this, and I said possible, is to poll your server frequently to check if there is a need of update. The main inconvenience with this approach is the more you will reduce the update latency, the more you will drain your user battery. Google Cloud Messaging helps you avoid polling your server by offering a push message service. So now you are able to send a message directly from your application server to an installed application on a targeted device. So there is no need to poll your server anymore. If the device is offline when the message is sent, GCM will take care of queuing them and will deliver them later when the device will be back online. With GCM, you can send 2 kinds of messages. The first one is send to synchronize message, and the second one is message with payload. A send to synchronize message is also named collapsible message, because if you send 4 messages to an offline device, when the device will be back online, it will receive only 1. The other will be discarded. This kind of messages is really useful when you want to tickle your application to notify there is a need of update. The opposite of this kind of messages is the message with payload. It's a non-collapsible message. So if you send 4 messages, your device will receive 4 messages. You can have up to 4 kilobytes of payload data, but there is a main restriction. The delivery order is not guaranteed. So it's your job to add a time data to be able to reorder the messages when you receive them. The other restriction is you can have more than 100 non-collapsible messages per queue. If you exceed this limit, all the messages will be discarded and you will receive a special message in that case. So what are the main advantages to use Google Cloud Messaging? The first one, it will help you reduce the update latency of your application while preserving the battery life of your users. GCM is now part of Google Play services and it's available back to Android for you. There is no quota limit, so you can send as many messages as you want, and you can send a message to one recipient or many. And one cool thing is that the application doesn't need to be running in order to receive messages. In GCM, we can identify 2 phases. The first one is a registration flow to enable the communication pipeline between the server and your mobile. The second one is when the registration flow is over, it's a message flow, when your application server will send a message through GCM services. The registration flow begins on the mobile side. You are going to ask a registration ID to GCM. This registration ID is unique per installation per device. So the same application on different devices will have different registration IDs. So GCM will send you back this registration ID. You should send this information to your application server for later use. It will have to store this information. When the registration flow is over, you have to store the registration ID with the application version in the shared preferences of your mobile, because there is no need to register again. except in two cases. The first one is when you update your application. In that case, there is no guarantee that the registration ID is still valid. And the second case is when you back up your application. You shouldn't store you shouldn't save the registration ID when you back up an application. So now we are able to receive a message from our application server. The server will just send a request to GCM services, including the registration ID inside the message. And GCM will take care to deliver this message to your installed application on the targeted device. For the next part of this presentation, I won't discuss some prerequisites. The first one is you need to have a Google account because you will have to create a project in the API console. It's a console where all the services of Google are available, and you have to enable the Google Cloud Messaging service in that console. From this project, you will need two informations. The first one is the project number. This information will be used by your mobile to identify the sender of a message. The other name for the project number is sender ID. Then you will need a server API key. It's an authorization key to authorize your server to send message to GCM service. So now we can go on the server side to see how to send a message to GCM. It's very simple because it's just a post request on this URL. But you have to add two headers which are required. The first one is a content type that will define the format of the request. You can choose between JSON or plain text. The plain text is a default one if its header is not set. Then you will need the authorization header. You have to put your API key inside this authorization header to let your server send message to GCM services. Finally, depending on the content type of your header, your message will have a specific format to be processed in order to be processed by the GCM services. Here is an example of the JSON message format. There is 6 fields. Only one is only required, the registration IDs. But we are going to begin with the collapse key. Collapse key field will make the difference between a collapsible and non-collapsible message. If you set this field, it will be a collapsible message. You can put any arbitrary string in this field, but there is a limitation. You can't have more than 4 collapse keys per device at any given time. If you try to exceed this limit, you will have some problems. Then you have the time to live. It's the amount of time that your data will be available, will be retained by the GCM service while the device is offline. When this amount of time is exceeded, the message will be discarded. One interesting option is the delay while idle. If you set this field as true, when you send a message and your device is not sleeping, then GCM will wait that the device is back online before delivering the message. Then you have the data field. You can put any key value pairs in this object, and each key will be interpreted as an extra in the intent that you will receive in your mobile application. Then we have the restricted package name. When you set this field, the message will only be sent to a registration ID that match the package name. The dry run is really useful when you are a developer because when this field is set to true, the message will be processed by GCM services, but GCM won't send this message to devices. So it's really useful when you are implementing a push server. Finally, we have the registration IDs. So you can put up to 1,000 recipients in this field, and you just have to put the registration ID that the mobile sent you just before. Here is a sample request with Node.js. So you can see it's really simple. You just have to define the post request with a URL. We can see there are the two headers, content type authorization, and in our case, we send a collapsible message to 6 recipients. When you send this message, GCM could answer this one. It's a response format. It means it's a response you get from GCM when you send the message from your server. The first field is a multicast ID. It's the unique ID of your message. Then you have some statistics on success and failures. But the most interesting part is the results field. Each result will come in the same order as the request ID in the previous request. So you need to keep a reference of your previous request in order to match a result with a registration ID. The first result is a success. You get a message ID. The second one is an error saying that the service was not available. In that case, you should retry to send your message. The third one is an invalid registration. It can happen when your data is corrupted or you received a registration ID that is not associated to your project number. The fourth one is a success, and the fifth one is a particular case. It's a specific case. It's a success, but the registration ID needs to be updated. So you have to update the registration ID of the fifth recipient by the new value set in the registration ID field. And finally, one common case is not registered. You will receive this kind of error when your application will be uninstalled by your user. So you can't send a message to this device anymore. The consequence is you just have to delete the registration ID from your database. So now we have seen how to send a message to GCM from your application server. Now we are going to see how to register to GCM from your mobile application and how to receive the message from your application server. First, everything in Android is a question of permissions. The first one is the internet, because you will receive the message over the internet. The second one is the get accounts. This one is only used for device that is running on pre-ice cream sandwich version. This permission is required by the Google Play Services library. The third one is the wake lock, because you can receive a message while your device is sleeping, so you will need to put a wake lock to avoid your device to go sleep. Finally, you will need a permission to receive a GCM message. And finally, the most important is to create a custom permission. This custom permission has a specific format, which is the package name plus the permission.cdm message. So in our case, it's com.devox.gcm. This custom permission is really important because it will prevent other applications to steal your message. Now, GCM is part of Play Services, so you have to check if Play Services are available on your device. For that, you have a command class named Google Play Services util with a method is Google Play Services available. If the result code is not a success, you have to check if it is a user recoverable error. In that case, you can get an error dialog to show to your user in order him to act to resolve this problem. In real life, what happens? A dialog pop, the user click OK, and it will be redirected to the Play Store on the Play Services application. If it's not recoverable, it's up to you to decide if the GCM is really important in your application or not. This method must be called in your onCreate and onResume of your activity. Why? Because if the Play services are not available, you are going to pop a dialog. The user will click OK, I go on Play Store. But when he will come back to your application, the onCreate method is not going to be called. So you need to check in onResume if Play services are still available. So now we are sure we have GCM available, we can register. To begin, you need to get an instance of the Google Cloud Messaging class, and you can call the register method giving the sender ID as a parameter, the project number. You have to do this in background because the register method is a blocking one. When you receive the registration ID, you have to send it to your server, and if you successfully send your registration ID to your server, you need to store this registration ID into your shared preferences with the application version. So now we are able to receive a message. For that, we just have to declare a GCM broadcast receiver, and it should extend the new wakeful broadcast receiver. The wakeful broadcast receiver is an utility class that will handle the partial wake log for you. So in our case, the only thing to do is we receive an intent from GCM. We just set the component name of the service that is going to handle our message for us, and start a wakeful service. So now we are on the service side, and we are going to handle our message. We can check that there is extra. This could be done on in the broadcast receiver. But then we are going to get the Google Cloud Messaging class during the registration, and we can get the message type. There is three kinds of message. Send error. It's sent when something went wrong with when sending the message. The second one is message type deleted. It's a special message that you receive when messages were discarded from the queue. When you exceed the 100 non-collapsible messages per queue. So you will receive this kind of messages with the number of messages discarded. And then the current one is the message type. So it's a classic one, and you will get all the information from your server by the name. You can get the value of a key directly from the extra. So if you send a message with data, message, and a message, you will get an extra message. So you can get the message from your server like that. And finally, don't forget to complete the wakeful intent, because it will release the wake log for you, and it's really important to not forget this statement. So now I'm going to talk about some news from GCM. During this presentation, I mainly discuss about GCM over HTTP. Why? Because the protocol used during the communication between our application server and GCM services is HTTP. It's a downstream communication, so only a message can go from your application server to your device. In the other way, it's not possible. That's why Google designed GCM Cloud Connection Server. So now, the communication can be bidirectional. So you can send a message to a device, and a device can answer to this message. But the protocol between your application server and GCM will be XMPP and not HTTP. There is an extra field that is used for this kind of of GCM version, which is the 2. Instead of including the registration ID in the registration IDs field, you will add your registration ID in the 2 field, TO. And one other feature is the user notifications. The user notification will let you create a group of devices. Because in the real life, a user can have multiple devices, and it's really interesting to be able to create a group of devices to identify a user. So you will match a notification key to this user with a group of devices. So there will be a first step to create the user with a number of registration ID that represent his devices. And then you will be able to send a message directly to the user. And if the user, for example, if your user has 3 devices, 2 are offline and 1 is online, when you send a message, the message will be received by the device which is online. And if the user processes this message, the other message will be discarded from the other queue. So the other devices won't receive your message. It really helps to improve the user experience of your application if you use this kind of feature. So now it's time for a little demonstration. So we are going to. Here is a sample project. It's an Android application that will receive the message and display the message it has received. So I'm going to just launch. Oops, sorry. Check that I have an internet connection. Okay. So Gradle is going to build my project and deploy it on the Nexus 7. And it's taking a little time. Oops. So I've logged some details. I've requested a registration ID, got my registration ID, tried to send my registration ID to my server, and it was okay. So my registration is done. I can check it on my server. It's just a node server, so just check, and yeah, I have a registration ID. So now I'm able to communicate with my application. So I will send, for example, I from GCM. Just send. Oops. It's a beautiful user interface, I know. Oops. And it's okay. And you can see that the message is now displayed on in the mobile application. So in many Android presentations, there is a tips slide, and we'll try to give some advice through GCM. The first one is you have to prefer the send to sync. Oops. The first advice is you have to prefer send to sync messages over payload, because it will make your client implementation way more easier if you use send to sync messages. The second one is, oops, don't forget the time to live. Why? Because the default time to live of GCM is 4 weeks. I'm not sure that your user is interested by an information that is 4 weeks old. So you need to always define a TTL that represents the real time to live of your data. And the last advice is don't spam your users. There is nothing more annoying than an application that sends a lot of notification. You have to detect what is a really meaningful notification for your user. So try as possible to avoid spamming your users. So now this presentation is over. So any questions?
I see the delay being quite short in this presentation.
The delay?
Press send and it immediately pops up.
Ah, yes, the delay while idle option. Okay.
Yeah. So what's the maximum delay that you have noticed? I heard people say it can be 20 seconds.
It's difficult. It depends in the case, so I can say I don't have this information. It's up to GCM to decide when to send this message. So when it detects the device is back online, it may delay the message in order to preserve the battery of your user. So we can't have the hand of how many seconds it will wait before sending the message.
Okay. But even if it's online, then you know.
If it's online, there is no guarantee of delay. So there are some special cases where you send too many messages in a short lapse of time, and it may throttle the message. So it can delay the message in order to preserve the battery of your user. It's something that can happen if you send too many messages to your user. So yeah, a 20 seconds delay can happen to a message. Other questions? So thank you very much.